History of the Atom by Reid and Rachel. Democritus was one of the earliest people to imagine what the smallest particle would be. He called the particles atoms or atomos, meaning uncuttable. All things were said to be made of atoms, and the characteristics of the matter was caused by the particle's texture and or size. The atoms stick together to form bigger matter. His ideas were not widely spread due to his rival Aristotle having a different idea of the nature of the universe.
Aristotle was one of the, if not the biggest philosopher of his time. His atomic theory stated that there were 5 elements: fire, water, earth, air, ether. Air's property were light, water was wet, earth was cool and heavy, fire hot. Everything was made of these elements, or one or more of these elements, and the elements, no matter how much they were divided, would be the same. Being as famous as he was, Aristotle's theories caused the advancement of the atomic model to be halted for a while.
Antoine Lavoisier was a French chemist who helped lead the discovery that mass was not lost in a chemical reaction. He realized that in 1772 to 1794 that during a chemical reaction there is no loss of mass. This led to an important law called the Law of Conservation of Mass to be created. It states that matter can neither be created nor destroyed.
John Dalton was a scientist known for devising a rudimentary atomic theory, which stated the following: all matter is made up of atoms. Atoms are indestructible. All atoms of a given element are identical in mass and property, and compounds are formed by 2 or more different kinds of atoms. And a chemical reaction is simply a recombination of atoms. His theory was almost sound, other than the exception of that atoms of the same element do not have the same mass, as there are isotopes of different masses, and that atoms cannot be destroyed as they can.
J.J. Thomson helped discover the existence of electrons. He discovered the electron and its negative charge by using a high vacuum cathode ray tube. His atomic model consisted of a positively charged sphere with negatively charged electrons embedded in the spheres. These discoveries helped forward the model of the atom.
Robert Millikan's major contribution to the atomic theory was measuring the mass and charge of an electron. To do this, he had used a perfume bottle to spray oil into a contraption with 2 charged plates and X-rays shooting electrons from the bottom. The electrons would go into the oil and cause it to float due to the charge from the extra electrons and the plates being negatively charged. He then calculated the force of gravity compared to the charge, compared to the height, and along with the max velocity or terminal velocity, and thus he learned the charge of a neutron and the mass.
Ernest Rutherford found out and confirmed that atoms have positive cores in space and electrons around them. He also realized that atoms had half-lives and suggested using this as a natural clock. This helped track the age of the Earth. He found out that atoms were mostly space and had estron around them by shooting radiation into a gold sheet. The radiation would bounce off the sheet or be absorbed into it. He realized that the particles must have a charge in the center to be reflected.
Louis J. Broglie is known for his work on the electron waves. Now, most people at the time believed that electrons moved in orbits, or circular orbits, in a uniform manner, but he believes that instead, the electron was restricted in a manner and was forced to orbit around the nucleus, but not in any particular fashion. This led to the most current version of the atomic model. especially that of Bohr's atomic model, which had electrons of a fixed orbit orbiting around the nucleus.
James Chadwick helped confirm the existence of a neutral particle in the nucleus of an atom. The existence was found when he used previously known research where radiobiology was shot into wax. He furthered this and realized another particle of neutral charge must exist along with how the masses double of more of the element he believed a neutral particle, which was a combination of a proton and an electron. Now we go back to Ernest Rutherford's model, which is now used currently. It was proven later that his model was correct.